Hi everyone, I am Geetha, Assistant Professor, Department of Mathematics, SNS College of Engineering. In this session, we are going to discuss about half-range sine and cosine series. Already we know that Fourier series are a powerful mathematical tool used to represent periodic functions as a sum of sine and cosine terms. This representation allows us to analyze and understand complex periodic phenomena in various fields, including signal processing, acoustics, and heat transfer. Periodic function and Fourier series. A periodic function repeats itself over a fixed interval. Fourier series can represent any periodic function no matter how complex by decomposing it into a sum of simpler sine and cosine function. Sine and cosine component. The series consists of sine and cosine terms with different frequencies and amplitude. Fundamental frequency. The frequency of the first term in the series is called the fundamental frequency. Harmonics. The remaining terms are called harmonics, which are multiple of the fundamental frequencies. Coefficients. The amplitude of each sine and cosine terms are determined by the coefficient calculated through integration. Half-range sine series. Half-range sine series means the Fourier series f of x contain only sine terms. This half-range sine series represents a function defined on a half interval by extending it into a odd function. Sine series, a function f of x in 0, L can be expanded as a Fourier series of period 2L containing only the sine terms by extending f of x suitably in minus L, 0. So, here the f of x value will become summation n equal to 1 to infinity bn into sine of n pi x by L. Here, the bn value is evaluated by the formula 2 by L into integral over 0 to L f of x into sine of n pi x by L into dx. In half-range cosine series, the Fourier series contains only the cosine terms. A function f of x is defined in the interval 0, L can be expanded as a Fourier series of period 2L containing only the cosine terms by extending f of x suitably in minus L, 0. So, here the f of x is represented as a0 by 2 plus summation n equal to 1 to infinity an cos of n pi x by L. Here, an is calculated by the formula 2 by L into 0 to L f of x into cos of n pi x by L into dx. And a0 is calculated by the formula 2 by L into integral over 0 to L f of x into dx. Consider the following example. Here we are going to expand x into sin x as a cosine series in the interval 0, pi. So, here f of x will be considered as a0 by 2 summation an cos nx. An is calculated by the formula 2 by pi integral over 0 to pi f of x into cos nx into dx, and a0 is calculated by the formula 2 by pi into 0 to pi f of x into dx. So, a0 is equal to integral over 0 to pi x sin x into dx into 2 by pi. So, here we integrating this function and substituting upper and lower limit, we get a0 value is equal to 2 and an is equal to 2 by pi integral over 0 to pi x sin x into cos nx into dx. Here we are going to use the formula sin x into cos nx can be written as sin a plus b into a plus b plus sin a minus b divided by 2 formula. After that, the multiplication will become plus. So, after integrating sine we get minus cos. So, substituting the interval 0 to pi, we get the value minus 1 into minus 1 the whole power n plus 1 divided by n plus 1 plus 1 by 1 minus 1 into minus 1 the whole power 1 minus n. After that, by simplification we get 2 into minus 1 the whole power n minus 1 divided by n square minus 1. this value is only for n not equal to 1. If n equal to 1 means we substituting n equal to 1 in an formula. So a1 will become 2 by pi integral over 0 to pi x into sin x into cos x into dx. So here the 2 sin x into cos x can be written as x into sin 2x. Then using the Bernoulli formula, integrating, we get a1 value is equal to minus half here. Here we are using the concept 2 sin x into cos x can be written as sin 2x. So then only we can integrate this value. So after the finding a1 value, the f of x Fourier series will become x sin x is equal to 1 minus half into cos x plus 2 into summation n equal to 2 to infinity minus 1 the whole power n minus 1 divided by n square minus 1 into cos nx. So properties of half range sine series. This half range series is series possesses unique properties that make them valuable for representing function with discontinuities or specific boundary conditions. Convergence. The series converges to the original function at the point of continuity. Discontinuities. At the point of discontinuity, the series converges to the average of the left and right limit. Boundary conditions. Half range series can satisfy specific boundary conditions such as zero values at the end of the interval. Periodicity. The extended function is periodic with a period twice the original interval. Coming to the application, the half range sine and cosine series find diverse application in various fields including physics, engineering and signal processing. Heat transfer. Modeling temperature distribution in objects with varying boundary condition. In vibration, analyzing the motion of vibration system such as strings or membranes. In signal processing, representing and analyzing periodic signal such as audio waveform. Wave propagation, modeling wave phenomena such as sound waves or electromagnetic waves. Thank you.